I'm John Wilker, the organizer of 360 IDEP. I hope you enjoy this session recording, but first I wanted to mention one thing. We've served the community since 2009, and over the past few years we've had to take on debt in an effort to keep the conference alive. After several unforeseen challenges, not the least of which is a pandemic of indefinite duration, we've had to make the hard choice to end the conference as we're now facing over $100,000 in debt. As a result of requests from the community of how they can help, we've created a GoFundMe campaign. If you're inclined and able, please consider donating to help keep 360 IDEP going. The QR code after this will link you to the campaign. Thank you. Enjoy the recording.
Good morning. Yeah, all right, I'm excited to be here. And I know I have some coworkers from my last job that are here and from my current job. And I have some good friends from Women Who Code and from conferences I've attended in the past that are here. And my husband's here, so thank you all, everyone, for being here to support me. And I want to say thanks to John and Nicole for inviting me back to speak for the third time. I don't know if I've gotten any better since then, but I hope you all learned something from it. So thanks for being here. All right, so welcome to my talk called When You Can't Go All In on SwiftUI, Build a Hybrid UI App Instead. And my name is Vui Nguyen. So let's start off with an app we want to build. How about something simple to start, like a tip calculator? Should we use SwiftUI to build it, since that's what Apple wants us to do? Well, let's see how this tip calculator turned out. So you can select the different tip percentages by tapping on the segment control. Well, I mean, this looks fine, but I sure wish I could customize the colors on the segment control. Like, wouldn't it be nice if we can make the indicator a dark color so that you know which tip percent was selected? And in fact, the project states that we want the selected indicator to be a color that stands out. So this isn't meeting requirements. All right, well, let's see if we build this tip calculator in UIKit. Let's see how that looks. So this looks a lot better. The selected indicator is a dark color, so you can see which tip percent was actually selected. But we built this in UIKit, so it feels like we're going backwards, right? We're going back to the dark ages. Maybe we can select something that on the screen that we can rewrite in SwiftUI. Like, for example, the tip amount and bill total, they look similar except for the values of the text and the dollar amounts. So maybe we can rewrite that as a reusable SwiftUI component, for example. And, well, you know, guess what? You don't have to pick and choose like which UI framework you want to build your UI. You can mix and match, and I can show you how to do that in this talk. But before we get much further, let me introduce myself. Again, I'm Vui Nguyen. I'm a longtime software engineer, worked across many tech stacks for 20+ years. And over that time, I had to learn both new technologies and maintain old technologies. I'm currently a native iOS developer, but I started my mobile development career as a cross-platform dev, which may explain my interest in interoperability. And I've also worked on hybrid Objective-C and Swift apps. I also enjoy feeding animals at zoos. So let's go over what we're going to talk about today. I introduced the problem we're trying to solve. How do we build hybrid UI apps? And I've introduced myself. I'm going to talk a little bit about why we want to solve this problem. And then before we go much deeper into the how, I'm going to explain the UI flow and how that's different between SwiftUI and UIKit. Then I'll do a quick code overview of the tip calculator in UIKit, as well as the tip calculator in SwiftUI. Now that we have a foundation, I'm going to go over several different use cases we're going to explore today. The first one is when we have a single screen SwiftUI app and we want to swap out a component within that screen with UIKit. The second use case is when we have a single screen SwiftUI app and we want to add an entirely new screen in UIKit. Then we're going to switch gears a little bit and look at a single screen UIKit app and swap out a component in that screen to SwiftUI. And then our last use case we're exploring today is when we have a UIKit app and we want to add an entirely new screen in SwiftUI. I'm going to share some resources, include if you want to do some additional learning on your own, including the links to my project code. I won't have time to do a deep dive into UIKit or SwiftUI, however, so I hope you have at least a foundation in those frameworks to get the most out of my talk today. So why do we want to solve this problem? Well, if you've been working in tech for any amount of time, you know that you're going to have to maintain some legacy apps, but technology keeps on changing, so ideally you want to keep current with modern technologies as well. What if there is a way that you can leverage the strengths of other frameworks on an as-needed basis? And if you are migrating from UIKit to SwiftUI, for example, you don't have to do it all overnight, and it doesn't even have to be 100% complete. And in fact, if you want, your app can stay hybrid forever, and the hybrid ratio will just depend on your particular project needs. And you can do all this while minimizing your project risks. So let's take a look at the flow in UIKit. I'll just give a very simple example with pressing a button. Right, so the user presses the button, that creates a button tapped event, which changes the state of the app. So now the button state is tapped, and then you want to somehow inform the app of the state change. That way, through an action or delegate, the app can update its own display, in this case, display a label that says button tapped. Now with SwiftUI, you get some shortcuts, because the nice thing about SwiftUI is you can bind views to the states of variables. So you can cut out the middleman of, oh, I need to inform the app that the state has changed and then tell the app to update itself. All you have to do is change the variable, the state of the variable, and the UI, listening to changes in state, can update itself. So now that we know that there's differences in the flow between UIKit and SwiftUI, there's some takeaway points I want you to keep in mind as I'm going through the different use cases. So building a hybrid UI app is possible as long as in a SwiftUI app, make sure to add code to your UIKit components or screens so that we can inform the app when a state has changed, and then that way any views listening to those changes in state can update themselves. And then when you're in a UIKit app, you need to use the correct property wrappers to bind data to SwiftUI views so they know what to listen to, and then publish variables that you want UIKit views or view controllers to listen for changes to. So before we go into the different use cases, let's go over briefly the code for the tip calculator in UIKit. Now, keep in mind for these code snippets, I took out styling and other things. That way I can fit on the slide just what thing I want you to focus on at the moment. So here we have the tip percent segmented control, and we are adding a target action to it, which is a UIKit pattern. And that way we can inform the app that the tip percent has changed and to call update display to update the tip amount and bill total views. We also want to inform the app when the bill amount changes and to call update display so that the tip amount and bill total can be updated. We do this through the delegate pattern of UIKit by implementing UI text field delegate, which gets called when the value in the bill amount text box changes. So then when the app has been informed that either the bill amount or tip percent has changed, update display gets called, which updates the tip amount and bill total views. So now that we know how the tip calculator works in UIKit, let's go over how it works in SwiftUI. So we start by binding the state variable selected tip percentage to the picker, which is a SwiftUI segmented control. That way changes to the picker can update the selected tip percentage variable. And we want to have this calculated amount view, which is a reusable SwiftUI component, to listen to changes in selected tip percentage and recalculate and redisplay the updated tip amount and bill total as needed. We also want to bind the bill amount state variable to the text field so that changes to the text field can update the bill amount variable. And then once again, we want calculate amount view to listen to changes in bill amount and recalculate and redisplay the updated tip amount and bill total as needed. So now let's take a look at our reusable SwiftUI component that we call calculate amount view, which will be used to display either the tip amount or the bill total depending on the label type and the amount type. So here we're in the preview screen for the calculated amount view, displaying what the tip amount view would look like. Now back in the content view, notice we have two calculate amount views. One is used to display the tip amount and the other is used to display the bill total. And also this is how they look like individually in the SwiftUI preview windows for each of them, and also how they look like together in the preview window for the entire screen. Now that we've done a quick overview of the tip calculator code in both UIKit and SwiftUI, let's go over the first use case. So let's say you have a single screen SwiftUI app and you want to add a UI component in that same screen. So I mentioned earlier how I really don't like that segmented control couldn't be customized. So we're going to swap that out with a UIKit segmented control. That way we can add color to that selected indicator. And here's a quick demo. So it behaves pretty much the same way, but now it looks a little bit better, I think. So to start, we want to take the picker, which is our SwiftUI segmented control, and we're going to remove that and replace it with segmented control. Segmented control is the new SwiftUI view that we're going to create, which is a wrapper around UI segmented control, which is a UIKit component. So since UI segmented control is a UIKit component, in order to drop it into our UI screen, we need to create a SwiftUI wrapper around it. To do this, we implement the make UI view function of the UI view representable protocol, which is an Apple API. and that will create a SwiftUI view wrapper around our UI segmented control. Notice how we add the target action to the UI segmented control inside the make UI view function, just as if it was a regular UIKit component. Notice also how the action function is defined in something called a coordinator, which I will explain in a little bit. So in the UI view representable protocol, we also have an update UI view function that needs to be implemented. Update UI view updates the segmented control display when the user taps on the segmented control. Notice something called a context. This context stores the state of the app, and we get to the state of the app through a coordinator. Since segmented control is under the covers, a UI segmented control or UIKit component, we need to use a UIKit pattern to inform the app when the segmented control has been tapped and the selected tip percentage variable has been updated. We do that by making a coordinator. Note this coordinator is not the same as the UIKit navigation pattern. This coordinator is part of the Apple protocol UI view representable. And since the coordinator is an object that has access to the context or state of the app, we use the coordinator to implement the UI segmented control's target action pattern, which it is doing through this tip percent change function. Tip percent changed then informs the app when there are changes to the selected tip percentage. And once the app has been informed of changes to selected tip percentage, then whatever views are listening for those changes can update themselves. And here we implement the make coordinator function of the UI view representable protocol to make a coordinator available for the segmented control. And of course, once the coordinator is available, then the coordinator can implement the missing UIKit pattern we need for our segmented control. Now that we've gone over how the segmented control was implemented, let's go back to how updating tip percent updates the calculation for tip amount and bill total automatically. The segmented control listens for when the user taps on the control and changes the value of the selected tip percentage. The tip amount and bill total boxes are listening to changes in the selected tip percentage and automatically updating their calculations and redisplaying their values when selected tip percentage gets updated. Also, when bill amount changes, that automatically updates the bill amount used in calculating the tip amount and bill total. Again, we don't have to inform the tip amount or bill total views that the bill amount has changed and therefore recalculate the tip amount and bill total. And that's because that happens automatically since the bill amount variable was bound to those views, i.e. those views were listening to changes in bill amount. So I know that was a lot, so let's recap what we just went over. When you have a single screen SwiftUI app and you want to add a UIKit component within that screen, we need to implement UI view representable protocol. This creates a SwiftUI wrapper around the UIKit view, and the coordinator pattern implements our missing UIKit target action pattern. Now that we know how to add a UIKit component to a SwiftUI screen, let's go over our next use case. So our next use case is when we have a single screen SwiftUI app, and now we want to add an entirely new second screen in UIKit. So going back to our tip calculator, let's say once we've determined our tip amount and our bill total, now we want to figure out how we want to pay. So we do that by creating a second screen that will allow us to select our payment method. And once we select the payment method on the second screen, we go back to the main screen and that displays the payment method that we selected. So let's see the demo. A fun little thing about this is depending on which tip percent you select determines which image you see on the second screen. And then whatever payment method you select on the second screen gets reflected back on the main screen. Okay, so let's start on the main screen. We want to add the Pay button and the Paid By label. They will be displayed or hidden based on the state variables payment method and pay state. We also need to be able to segue to the payment screen once we tap on the Pay button. This is possible through the navigation link, which will open the payment view controller or the payment screen when we tap on the Pay button. So let's create a new payment view controller storyboard for our second screen and a payment view controller to go with it. Notice we also have a protocol payment view controller delegate that we need to implement. When the user taps on the payment method segmented control, the payment method gets updated. We then need to inform the app through the delegate function payment selector that the payment method has been updated so that the app through the delegate can act on this change in state. So for example, we'll want to update the Paid By label on the main screen with the payment method once it's been selected. This is the delegate pattern of UIKit. But in order to use this UIKit screen payment view controller in our SwiftUI app, we need to create a SwiftUI wrapper around it. We create a SwiftUI wrapper called paymentViewController.view by implementing the UI view controller representable protocol. To create a SwiftUI wrapper around payment view controller, which is a UI view controller built from a traditional storyboard, we need to implement the make UI view controller function, which is part of the UI view controller representable protocol. We're required to have an update UI view controller function because it's part of the protocol, but there's nothing in it since there's no component on this screen that needs to be updated as a result of a change in state. That's because when the payment method segmented control gets updated, we want to inform the main screen of this, which will happen through the delegate method. But there's nothing on the payment screen outside of the picker that needs to be updated as a result of the segmented control's new value. Now, remember earlier I said we need to implement the payment view controller delegate protocol? So here we are implementing the payment selector function of payment view controller delegate. In payment selector, we take the payment method that the user selected from the payment segmented control, and we set it to the state variable payment method. We also want to set the pay state to paid. We are using the at binding for the state variables here because the delegate could change the values of the state variables, and we want those changed values to be reflected back to the main content view. But who creates the payment view controller delegate? Well, the make coordinator is where we create a payment view controller delegate. And that's because the coordinator pattern allows us to implement the delegate pattern for UIKit view controllers within a SwiftUI app. Remember, this coordinator pattern is part of the UI view controller representable protocol and is not the same thing as the very popular UIKit navigation pattern by the same name. Now, let's go back to the main screen. Now that the state variables have been updated, we can hide the pay button, which has been listening to the value of pay state. Also, when pay state and payment method are updated, that will allow us to show the paid by label and display the payment method that was selected in the second screen. All right, so let's quickly recap what we just did. When you have a single screen SwiftUI app and you want to add an entirely new screen in UIKit, We do that by implementing the UI View Controller Representable protocol. This creates a SwiftUI wrapper around our UIKit view controller. And the coordinator pattern implements our missing UIKit delegate pattern. So we went over a couple of use cases with SwiftUI apps and adding either UIKit component or UIKit screen. Now let's shift gears a little bit, look at a couple of use cases starting with a UIKit app. So let's say you have a UIKit app and now you want to add a SwiftUI component. So going back to our famous tip calculator, as I mentioned earlier, I thought it would be really nice since the tip amount and bill total boxes look so similar that we can just replace those with a reusable SwiftUI component. And I made the font and colors look different in the new SwiftUI component, just so you can see easily how I made the change. And here's the obligatory demo video. All right, so in order to swap out the UIKit components for tip amount and bill total with a reusable Swift component, we'll first need to remove the original tip amount and bill total views and put container views in their place. These container views will segue to a couple of hosting view controllers, which will eventually hold our new SwiftUI views. Here's just a bigger view of the same thing. Now we want to access those segues in the code by adding IB segue actions. So this will show you how to do that. We want to control click on the segue to our view controller to create our IB segue actions, do one for the tip amount, and also do another one for the bill total. Now, IB segue action is a special segue to a UI hosting controller, which will hold our SwiftUI view, in this case, either the tip amount or the bill total. The calculated amount view will display either the tip amount or bill total depending on the calculated amount type, which is an enum of the value of the tip amount or bill total. Now let's take a look at our reusable SwiftUI component calculated amount view. This view is used to display tip amount or bill total depending on the value of amount label and amount. Also, this view is listening to changes in the tip percent and bill amount values, which are published properties of our view model. Now the appropriate values will show in the tip amount and bill total views, as you can see in the SwiftUI previews for the container views. Also, you can see what they look like when they're both together in the main screen. So let's do a quick recap. When you have a situation where you have a single screen UIKit app and you want to add a SwiftUI component in that same screen, we do that by adding a container view to hold a hosting controller, which will hold our SwiftUI view. We want to make sure to use the correct property wrappers in order to bind data to the SwiftUI views. And we want to publish variables that we want UIKit or SwiftUI views to listen for changes to. Now let's go over our fourth and final use case. I think by now you start to see a pattern, but we'll go on. So let's say you have a single screen UIKit app and you want to add an entirely new second screen in SwiftUI. Once again, we'll calculate our tip and bill total on the main screen and then select our payment method in the second screen and then go back to the main screen to display our payment method. But since the segmented controls don't look so great in SwiftUI, we're going to use buttons to select the payment method for our SwiftUI screen. So trying to leverage strengths of different frameworks here. And here's our demo video. And once again, The tip percent that you select on the main screen determines the image you see on the second screen. And tapping on a button, payment button on the second screen will display that value of the payment method on the main screen. Okay, so we want to start by adding the pay button and paid by label on the main screen in the storyboard. And we also want, when we tap on the pay button, to segue to the payment screen. So you start doing this by creating an IB segue action from the segue in the storyboard to the view controller. This is where we'll segue to the hosting controller. Now, we also need to add outlets for the pay button and paid by label. Notice also how the IB segue action returns a UI hosting controller. The UI hosting controller is a UIKit wrapper around the SwiftUI view that we want to present. In this case, we will be presenting the payment view, or the second screen, which we are building in SwiftUI. And here's the second screen payment view built in SwiftUI. Here we set the payment method based on which payment method button the user taps on. Also, by selecting the payment method, we're setting the pay state to paid. Finally, when we return to the main screen, the pay button is updated appropriately, in which case it will be hidden because we've already paid. And that's because payment method and pay state are published properties of tipper view model, and the pay button has been listening to changes in their states. Now, since UIKit views and view controllers don't bind to state variables the way that SwiftUI views do, we need to make our view model an observable object. And we need to publish the variables that we want our view controller to listen for changes to. This way, we don't have to inform the main view controller through a delegate or target action pattern that those published variables have changed, because the main view controller is already listening for those changes. But because the main view controller is still in UIKit, we will need to manually call the update pay section function to update the pay button when we return to the main screen. Through view will appear, and when the bill amount or tip percent changes. Also, when we return to the main screen, the paid by label is displayed with the payment method set from the second screen. And that's because, once again, payment method and pay state are published properties of our view model, and the paid by label are listening to changes in their states. All right, let's recap our final use case. So if we have a single screen UIKit app and we want to add an entirely new screen in SwiftUI, we do that by adding a hosting controller to hold our SwiftUI view. We want to make sure to use the correct property wrappers to bind data to SwiftUI views. And we want to publish any variables that you want UIKit or SwiftUI views to listen for changes to. So this might look familiar to you. Hopefully I've covered everything in this takeaway point. And here are some resources. I will also post the links to my GitHub projects in my channel in a little bit. Make sure to take a look at the branches before, after, and pay screen. They will show the different use cases that I went over today. And in case you're wondering how I drew those diagrams earlier with the UI flows, I used Excalidraw. And if you want to know how I formatted those code snippets, I used Carbon. And here's some resources and APIs from Apple. And I also use a really great tutorial by Ray Wenderlich on integrating UIKit and SwiftUI. And if you want to dig a little bit deeper and learn how to build SwiftUI views in table and collection cells, for example, there's a really great WWDC video on that. And to recap, this is what we went over today. And the 4 use cases. Any questions, connect with me. You may also email me at my work email, vui@atomicrobot.com. And I might give this talk again at another meetup or a conference, so I welcome any feedback on how I can improve it. Thank you. All right, so I haven't been watching Slack, but are there any questions? Yes? I'm sorry, can you repeat that, or do we have a microphone?
In case 1.
Yes. Oh, well, let's go back to that. Well, in that case, it was the segmented control, and I think typically to handle a segmented control, you use a target action pattern for that particular component. So I'm just going to take a while for me to go all the way back. Does that answer your question? Sorry, I'm bad at this. I needed to repeat that question. For the first use case, when we were swapping out that segmented control in the, was it SwiftUI screen, the question was, could we have used the delegate pattern instead of the target action pattern? And I think the target action pattern is typically how you would handle segmented controls. Steve, I don't know if you've been able to. Okay, fantastic. Any other questions? Yes?
Have you done any work about trying to somehow help comment last components, like the adapters, not rewriting all from scratch?
Let me rephrase the question and make sure I understand it. Like, have I done any work with writing adapters to do this sort of interoperability? Am I understanding your question correctly? Sure. That's a great question. So I'm using like the protocols like UI view controller representable and UI hosting controller and so forth, because those are in the approved Apple API. And I mean, there's like a lot of different ways we can implement the same things, right? But I personally prefer to use the Apple approved method of doing things, because when you try to do something completely different on your own, you might get some unexpected side effects. So I tend to stick with what Apple recommends. Yeah, but I mean, if you want to try writing your own adapters. Oh, gotcha. Like extending, adding on top of the protocols and stuff. Sure. I mean, I guess it's possible. I haven't tried that. Yes.
There's a question in the Slack. Will your slides be posted up on the email?
Yes, they will be. All right. Do you have any other questions? Well, if I'll be here for the rest of the day, so if any of you have any more questions, reach out to me, and and post questions on my Slack talk channel Slack later if you want. So thank you so much.